Hello students, welcome back to Vedantu JEE channel. Let me know first of all if I'm live, if I'm audible. You can see me and hear me clearly. Okay? Hear me part should be there and if you can see the screen. Hi everybody, welcome to this session. Let me start. Okay, we are live. I can see myself live right now. Okay. Let me look at the chats. Whoever is here. Hi Bacha. Hi Hari. Okay. Let me know if you can hear me and see me properly. Yes, NEET students can watch this because this topic is common, right? Chemistry is common for JEE, NEET, everything. Here only that it's only a tad bit more I'm going to teach here. But yes, NEET students can watch this. Hi Sajja, hi aspirant. Hi Rudru. Hi Rudru, welcome back. Welcome back. ठीक है. बस let me know कि मेरी voice is not, you cannot hear the echo of my voice. My voice is loud and clear and crisp. You can hear me just fine. ठीक है. Let me look at the chat once again. ठीक है. Yes, everything is fine. Okay, let us begin. So, bacha, what is this session for? This session is for the acidity and basicity order as well as your stability of species, right? Very important topics with regards to your JEE Mains exam. ठीक है. These topics are time and again asked, but there has not been any dedicated video to it yet. This session is going to help you to answer all the acidity, basicity, order related questions, whether it is for the alkyl groups or the aryl groups, right? Yes, bacha, I'm going to teach on this channel. Very basics we're going to start with because all my sessions, bacha, no matter which video you pick up, I start from the very basic, knowing that the child might not know how to even move the arrows. Okay? So in this organic session, if you're preparing specially for the JEE Mains April attempt, very important session because I've included 15 years of PYQs. We are going to solve all those PYQs, whatever acidity, basicity order was asked. Every question is here. We are going to look at how to solve those questions, as well as I will also discuss those examples which have the probability of getting asked in your next attempt. Okay? Because there's a trend that JEE follows, right? And because I have been in this line for so many years now, I can predict the trend, or I know like in which direction the trend is going, right? हाँ बच्चा, I'm going to teach all the organic from the very basics. We are going to do that. ठीक है? Now let us begin this session. Now first of all, we're going to look at the acidity and basicity order, and in the next we are going to look at the stability of species. What the stability? The stability of carbocations, carboanions, as well as your free radicals. All these stabilities we are going to look at. ठीक है? So first of all, can you look at the board? The board contains the stability of the factors affecting acidity and basicity order. What are the factors that you have to look for whenever in your exam the acidity or the basicity order is asked? Number one factor is the inductive effect. How it will affect, we are going to read about all these factors one by one, but you should know that all these 6 factors are responsible when you are looking for the acidity order, right? The inductive effect, the resonance effect, or the electromeric effect, or the mesomeric effect. These are the same things. And how are the same things? I'm going to let you know. Next is the hyperconjugation. Next is the aromaticity. Next is the electronegativity, and next is the charge. So can you see there are so many factors on which your acidity basicity order depends, and that's why there is a higher probability of you actually marking the wrong option in this trend. This seems easy, but it is not, because it depends on so many factors, and I will also write one 7th factor here. What can be the 7th factor? The 7th factor is steric hindrance, right? Steric hindrance. So all these factors we are going to discuss over here. ठीक है? And I have attached all the examples that are even possible from anywhere. Every example we're going to discuss in this session. ठीक है? But before that, I have again a very crucial important information to share with you guys, that Vedantu is coming up with the Sankalp batch for your IIT JEE preparation. So whether you're preparing for even the mains attempt in the April, so there is a crash course for these people. And if you are a student who is going to give the IIT JEE even in 2025, then you can start the beginners batch. This is, I'm talking about bacha, the offline batches that the Vedantu is providing. You can join the offline batch if you are in one of the cities that the Vedantu center is located, right? And why you can join this bacha? So that you are in a discipline, right? On YouTube, you are not disciplined, like sometimes few people are watching and after 10 minutes you just log out, right? Your brain just switches off, right? But it shouldn't happen with the offline classes, because they're physically present and you can join them if you're serious about your IIT JEE preparations. And here are the results of the Vedantu batch. Can you see that Vedantu has produced AIR 21 in this session 2024, AIR 21. Sorry, 2023, right? AIR 21, 28, 104, 59 and AIR 91 all in the 2023 batch. And we have had approximately 1500 good rankers in the 2023 batch, right? So if you want, you can join them and the link is in the description box below. Click on that link and you will know if the center is located near your city, in your city, then you can go and join. And if it is not in your city, then obviously YouTube is for the rescue, right? But YouTube is not the life, it is just the lifeboat, right? The boat that you keep on the side, so that, because I know that your attention span is not that great on YouTube, because I know how students are watching me right now. Okay? Yes, but I'm going to teach on this channel. This class is going to be for 2 hours. Okay? So I have told you about that batch. If you're interested to learn with Vedantu, then you can just join it. Otherwise, we are going to study on YouTube as we do always. Okay? The factors affecting acidity and basicity. Let us come back to the topic. The number one factor, bacha, is the charge. The charge factor is the number one factor. What do I mean by that? Now look at the example straight away. Can you look at here? The example is a OH minus, H2O and H3O plus. Between these three species, which is more acidic? So what is the meaning of acidity? Once again, acidity means anything that can give away H plus ion easily, right? That will be the most acidic ion. So between these three species, which has an extra H plus ion will obviously give away H plus ion easily. So can you see, as the positive charge is increasing, the acidity is increasing. So the positive molecule is more acidic than the neutral molecule, and the basic molecule is obviously not acidic, because this is going to be a basic molecule, right? Basic means what? Basic means anything that can give away its electrons, because it has a lone pair of electrons or it is electron rich, that is, it has a negative charge on it, right? One thing that you understood from this concept is what? That here, as the positive charge is increasing, the acidity is also increasing, right? Now look at the pKa order. One thing that every student has doubt in is the pKa order. What does pKa mean? Bacha, as much as the pKa is inversely proportional to your acidity. What do I mean by that? I mean that higher the acidity, higher will be the acidity, lower will be the pKa value, right? Higher the acidity, lower will be the pK value. Now look at the pK values over here. Here it has negative 1.7. It means the pK values can also go to negatives. Okay? And it is so much negative. Okay? It means that it is the most acidic molecule. Remember this relationship, that pKa and acidity are actually inverse relationships. Correct? Now again, look at this NH2, NH3 and NH4 plus ions. Can you look at this thing, bacha? Now what is happening over here? As the positive charge is increasing, right? This has the most positive charge. It is the most acidic, 9.2. Here 38 pKa, right? The neutral is less as acidic, and the basic species, bacha, will act as a base and not a acid. Okay? This everybody understood this point? Everybody understood this point? Okay? Next. Next is the next factor. The first factor we discuss is the charge. Okay. More the positive charge, more will be the acidity. Okay. Next is the role of the atom. Now here we are discussing, I again told you that the species which give away H plus easily will be more acidic. Okay, now look at this factor. Factor number 2, the role of the atom that we're going to discuss. Okay, now here can you see the role of the atoms? Now as this is your periodic table, as you are moving along a period, can everybody see? As I'm moving along a period, what is actually happening? The electronegativity is increasing, right? Electronegativity is increasing. Fluorine is more electronegative than your oxygen, then your nitrogen, and then your carbon. And to all these atoms, what is attached? H, hydrogen is attached. So which will give away its hydrogen more easily? So the more electronegative element will give away the hydrogen, the H plus ion, more easily. Why is that the case? Now look at the HF molecule. Because fluorine is more electronegative, which means it will attract electrons more towards itself, right? It is attracting electrons more towards itself, gets a delta negative, this gets a delta positive. Hence, this bond is easier to break. The H plus will leave and the H and the F minus will be here. Hence, HF is most acidic, then will be your H2O, then the NH3, then the CH4. So, along a period, I'm talking about along a period, as the electronegativity increases, the acidity of the H ion attached to it also increases. Now, look at the pKa order. Can you see that as I'm going from carbon to fluorine, the pKa is actually decreasing. Decreasing pKa means increasing acidity. Understood this point? So, understood this point everybody? Okay? Yes. Okay? Next, bacha, next factor number 2, the role of the atom again. So, the role of the atom is now we are moving down the group. Okay? Abhi I discussed along a period. Now, if you are moving down the group, then what will happen? What will happen to the acidity? Now, let's discuss about the 17th group. What is 17th group? Fluorine, chlorine, bromine, and iodine. Right? What will happen in this case? Now, again, the HI bacha here will be the most acidic over here. The HI will be most acidic. Can you see that the acidity is actually increasing here? Acidity increases. In this order, the acidity increases. Why is that the case? Again, acidity means that whatever molecule can give away the H plus very, very easily, right? Whatever molecule can give away the H plus very, very easily will be the most acidic molecule, right? So, what molecule can give this away? Now, look at the HI molecule. As we know that iodine is a very big molecule and hydrogen is a very little chotu sa molecule. So, the bond length between them, the HI bond length is very long, and we know that long bond lengths are easier to break. So, to break HI bond is easier. Hence, because bond breaking is easier, hence it will easily give away the H plus ion, right? So, as the bond length increases, the acidity also increases. Why? Because as the bond length is increasing, it is easier to give away the H plus ion. Right now, we're talking about the acidity in the order of how easily they can give away the H plus ion. So, I discussed two things with you. Two things. Number first is more the positive charge on it, more it will be acidic. Okay? The second point was more the electronegativity along a period, it will be more acidic. Okay? The third was more will be the size of the ion along a group. Now we're moving downwards, then more will be the acidity. Okay? More the bond length, more will be the acidity because it is easier to break. If it is easier to break, then the acidity will obviously increase because it is so easy to break. I don't have to put in any efforts to break, to take out this H plus ion. Hence, the acidity increases. Correct? Yes, HI is a very, very strong acid. Rudra is extremely right. Now, the next factor that we're going to discuss is about H2O and H2S. As you know that this oxygen and sulfur belong to the same group, group 16, right? They belong to group 16. Here comes oxygen is on the second period, then your sulfur, right? So as I'm moving down the group, what should be the trend? Because I'm moving down the group from oxygen to sulfur, which will be a stronger acid? Will it be H2O or will it be H2S? I just told you that if you are moving down the group, then the bigger molecule will form a longer bond. Hence, it is easier to break. So, the bigger molecule will be more acidic. So, H2S is more acidic than H2O. Can you see the pKa values? So, lesser the pKa value, more the acidic molecule. So H2S is more acidic. Similarly, look at this. Look at this case. This alcohol, this is a normal methanol and this is a thiol, right? Now what will be the acidity order which can give away the H plus easily? I just told you that sulfur will give away H plus easily. Hence, this is more acidic than your methanol. Everybody understood this point? Everybody understood this point? So 2 points we have discussed about the acidity order. Now let's move on to factor number 3. Very important factor is resonance factor. Okay? If whenever you are encountered with resonance, meaning what? What you are doing, when you are deciding on the acidity order, what you are doing. For example, look at this methanol molecule. So in methanol molecule, what will decide its acidity? After giving away CH3O minus, after giving away the H plus ions, this kind of base will remain, right? After giving away the H plus, what will remain? This kind of base will remain, which is called conjugate base. Remember this thing. This bacha is called conjugate base. Okay? So after giving away H plus, this base remains. Now, the acidity depends upon how stable this base is. Okay? If the stability of the conjugate base is so much more, then your acidity will always be higher. Okay? So I'm writing it here. Stability. Stability of conjugate base is more, then your acidity will also be more. Acidity more. Remember this point. Extremely crucial, important point that we're going to discuss over here. Now, the next factor that I was discussing was actually resonance. So, where will you see resonance? So, after the acid has given away the H plus, we're going to look at the conjugate base formed. For example, the conjugate base formed in the case of methanol will be this, right? And in the case of phenol, what will be the conjugate base? In the case of phenol, the conjugate base will look like this, right? The oxygen here has a negative charge on it. So can you see this negative charge can now go into resonance with the entire phenyl ring and can form so many resonating structures. So can you see that here in the case of phenol, the resonating structures are increasing. Hence, phenol is more acidic than methanol. Remember this point. Phenol is more acidic than methanol. Why? Because after this ion is, after the H is given away, this H plus is given away, what happens? This phenoxide ion remains. This ion, but the name of this ion is phenoxide. What is this? Phenoxide ion. Now this phenoxide ion, due to the presence of lone pair on oxygen, can undergo resonance with the entire benzene ring and can form so many resonating structures. Therefore, this is more acidic. Remember one more thing. More the resonating structures, more will be the acidity, right? If you have to compare between two species, so whatever species has the higher number of resonating structures will be more acidic. Remember this point? Everybody understood this point? Okay? Yes, phenoxide ion is very stable. Understood this point? Now look at the factor number 3 with more examples. Now we're comparing the methanol with your what? Carboxylic acid. Carboxylic acid. In both the cases, I'm going to make them lose H plus ion. Minus H plus, minus H plus, right? The H plus will go away from here. The H plus will go away from here. So this will form CH3O negative ion, correct? And this will form here it is C, double bond C, here it is O, and here it is negative charge, correct? So this kind of species is formed over here. Now see the difference between these two. Can you see that this species can actually undergo resonance, like the electron pairs can move here and this can move over here, right? So can you see a resonating structure is possible in the case of this carboxylate anion, but the resonance is not possible in your methanol. Hence, more acidic will be your carboxylic acid. Everybody understood? Can you look at the resonating structures here? So what is happening? This electron pair goes here and the double bond goes here, and therefore the negative charge comes here and the double bond comes here. Hence, more the resonating structures, more will be the acidic, will be the compound. Okay? Now I'm going to ask you one more thing. Which is more acidic? Which is more very important question, very beautiful question. Between number 1 molecule is your phenol molecule. Okay? This was asked in JEE 2024. Phenol molecule, and the next is your carboxylic acid molecule. Okay? Which is more acidic? Is this your acid or your phenoxide ion? Which will be more acidic? I'm going to name them as A and I'm going to name it as B. Which is more acidic? Yes, Rudra. I just told you more will be the resonating structures, more will be the stability. Remember this point once again. Can anybody tell me between A and B, what do you think? This was JEE 2024 question. Between these two, what do you think is the more stable species? Sorry, more acidic species. I am looking at the chat box. Please reply to me. Please, I'm giving you 60 seconds. Yes, please reply. Whoever is watching, please reply. Please reply. Between these two species, which is more stable? No, bacha, how CO3? No, it's wrong. Wrong approach, Rudra. Aspirant is saying A, and Rudra is saying B, carboxylic acid. In this case, Rudra is right. I told you. Even though ma'am you mentioned, I'm going to explain to you with structure so that you never forget this thing. In this, when this H plus goes away, what will be the conjugate base form? The conjugate base formed in this case will be the O negative ion, correct? This is the conjugate base. I'm writing CB below it. Remember the term conjugate base, very important. And if the H plus goes away from here, what will be the conjugate base form? I'm writing the conjugate base of this over here. The conjugate base formed will be COO minus, correct? Everybody is okay with the conjugate basis form after the H plus is given away. Now you have to tell which is more acidic. How to tell that? Now look at, I told you that in this structure the resonance will happen. How the resonance will happen? That the lone pair will go here and this will go over here, right? I'm making the resonating structure of phenol. So what will happen here? What will happen, for example, here the oxygen will get double bond, right? And here here a negative charge will come over here, okay? And here again. Now the next resonating structure is this will go over here, this will go over here, and it will again form another kind of resonating structure, which will be 1, 2, 3, 4, 5, 6, 7, 8, okay? Here it will be like this. Here oxygen with this kind of charge. Here the negative charge will come. Here it will again. So I can form too many resonating structures just like this. Everybody is familiar with this thing, right? But here I can form even 2 more resonating structures. I know this charge can again move over here and this will again move over here, right? So this will keep on going on, okay? But here, can you see, if I make a resonating structure of this, the resonating structure that I will get will be this will move over here and this double bond will move over here, right? This kind of resonating structure I will get, correct? So here what will happen? What will happen? The double bond comes over here and the oxygen here gets a negative charge. Okay, everybody got? So these are the two resonating structures in this case, and in this case, these are how the resonating structures can be made. I can make even two more resonating structures. Okay, because right now we're not learning about the resonating structures, we're learning about the acidity and basicity. Hence, I'm not going to put so much emphasis on here, but the thing that you should know is here the negative charge on both of these resonating structures in the carboxylate ion, what is happening? The negative charge is on the more electronegative oxygen atom, but here the negative charge, can you see, is actually traveling to the lesser electronegative carbon atom, right? Carbon atom. Can you see the negative charges on the less electronegative carbon atom? Hence, because in carboxylate ion, in the carboxylating resonating structures, what is happening? The negative charge is on the more electronegative oxygen atom. Hence, this is more stable than the phenoxide ion. More stable, more stable. Hence, when I compare the acidity between these two structures, then your carboxylate acid, the carboxylic acid will be more acidic than your phenol. Can you understand it? Everybody understand the concept behind it? Everybody understood the concept? Should I move forward? Okay? Everybody understood? So what is happening? You also have to look where the negative charge is going. Here the negative charge is going on the lesser electronegative carbon atom. Hence here the negative charge is not that stable, but it is much more stable on the carboxylate ion. Hence, even though the resonating structure of carboxylate ion is just 2 and the phenoxide ion has so many resonating structures, even then the carboxylic acid is a major, it is a more prominent acid, it is more acidic. This point should be clear to everybody. Between phenol and carboxylic acid, the higher acidic content will be of the carboxylic acid. Okay? Never get confused between these points. Now let us move forward. Everybody understood this? Now next factor that we were discussing was resonance. So you should know about resonating structures. So resonance can be bacha plus and minus. What do I mean by that? I'm going to explain to you. First of all, we're going to look at the plus M effect. The resonating effect has another name called mesomeric effect. It is the same thing, just the name changes. Resonating effect or mesomeric effect are the same things. What is happening? For example, look at this molecule OH. OH is what? OH has lone pair of electron. So what can this lone pair of electron do? And here a pi bond is present. Pi bond presence is very, very important. Okay? Pi bond is present to the same carbon atom to which the OH is attached. Okay, remember this thing that the pi bond should be attached to the same carbon atom where the electron rich group is present. Only then the resonance will take place. This kind of structure should be there. The carbon atom should have a double bond as well as any atom which either has a lone pair of electron or a negative charge, right? Only and only then the resonance will happen. Okay? So now what will happen? This lone pair will get donated to this single bond, right? And when this comes here, this double bond will move here, then this will again move here. So this kind of structure will be formed. So what is happening? Can you see that in this case, the oxygen, which was lone pair rich, which was electron rich, is giving electron towards, right? It is giving electron towards your alkyl or your aryl chain, right? It is giving electrons towards the chain. Hence, this kind of effect is called a plus M. It is increasing the electron density, right? It is increasing the electron density on the ring. Increase kar rahi hai na? It is increasing electron density on the ring. Hence, it is a plus M effect. So, any atom which has lone pair of electron or is electron rich or has a negative charge will act as a plus M effect. Plus M or plus R effect. ठीक है? ठीक है? Now next bacha, these are some of the groups which show this mesomeric effect plus M, which have the capacity to donate electrons. See, for example, your OH group, your OR group, your NH2, NHR, NR2. So can you see in all these species, there is a presence of a lone pair of electron, right? A lone pair of electron is present on every species, hence they can donate these electrons, right? Everybody understood this point? Everybody understood this point? Can I move on to the next slide? The next slide is now between these groups, which we have to decide the trend, because nobody will ask which will show plus M, which one will show minus M. What they will ask is, ki what is the trend, which will show more and which will show less. Okay? Here, now look at the very first point. The very first point, look at that very carefully. What have I written the order? The order of donating electrons is this, that CH2 minus will donate more electrons than your NH minus and then your O minus. Why is that the case? Can you see that if I am moving along this side, the electronegativity is increasing, right? Oxygen is more electronegative than carbon and your nitrogen, which means what? That it will hold the electrons more closely towards itself, right? Because oxygen is holding electrons more closely because it is more electronegative, hence it is not giving electrons to the resonating effect. So the atom that readily gives away, easily gives away electron will be the least electronegative element, which is your carbon, right? So CH2 minus will give away the electrons more easily than your NH minus and then your O minus. Everybody understood this point? Okay, the next is between NH and NH2. Between NH and NH2, which will give away the electrons more easily. So, bacha, NH will give away the electrons more easily. Similarly, between NR2, NHR, NH2 and these all molecules, which will give away the electrons more easily. So, bacha, I am going to tell you another thing. The R group that is present over here. The R group, bacha, is what? The R group is actually the alkyl group. The R group actually increases, shows another effect which is called the inductive effect, and also plus I. What is that? I'm going to teach you in this session only, don't worry. But remember that this shows plus I effect, which means the alkyl group increases. It is a electron donating group. What kind of group alkyl group is? It is electron donating. It is electron donating group. It means that it gives away its electrons very easily. It gives the electron. It is the electron donating group, increasing the electron density, right? So can you see that as the R group is increasing, the plus M effect. Plus M is what? Electron donating effect. So because the R group is already donating electrons to nitrogen, hence the nitrogen's capacity to donate electron increases, right? So as the R group increases, the electron donating effect also increases, hence the plus M effect increases. So NR2, then NHR, then NH2. Now can you see, as the double bond, whenever double bond comes, no matter what kind of multiple bonds, can be double bond, can be triple bond. So all these multiple bonds have only one function, which is a electron withdrawing function, right? So here, if the R group here was electron donating, here it was electron donating, right? The multiple bond group is actually electron withdrawing group. What it is doing? It is withdrawing electron towards itself. So I'm going to write here once again another point, that multiple bonds group. See, multiple bonds, any group can be. It can be C double bond O, it can be C triple bond N, it can be NO2. See, all these, whenever you see a double bond or a triple bond, you just have to see if any time multiple bonds are present, they are electron withdrawing groups. Remember this thing. This is the best trick to recognize which is electron donating, which is electron withdrawing. So whenever multiple bonds come, they're always and always electron withdrawing groups. So can you see, as the multiple bonds here increase, right? So the electron donating effect decrease because they are withdrawing the electrons towards itself. Correct? So the plus M decreases. Again here you can see all the other orders that I mentioned, they are based on the same principles that I taught you. As the electronegativity increases, the first point, the electron donating capacity is decreasing. Okay? Now again the trend over here is a little reversed with the fluorine, chlorine, bromine, iodine. The fluorine will give away electrons more easily, then your chlorine, then your bromine, then your iodine. Just remember this trend. I know it is contrast to the above trend, but this is a trend that is followed, so you have to understand this trend. Now let us move forward. Everybody understood the plus M effect? Plus M is anything which increases electron density in the ring. I'm again showing you this diagram. This diagram, always remember plus M effect with this diagram. What will happen? It is showing resonance and it is increasing the electron density on the chain. Correct? Everybody understood? Now let us move on to the next thing. Next is your minus M effect. Minus M. Okay? Minus M is what? In the plus M we were increasing electron density towards the chain. In minus M, I am doing what? I am decreasing electron density. Can you see here what is happening? Whenever a multiple bond, can you see there is a double bond over here? So this group is definitely what kind of group? This is electron withdrawing group. Remember this, EWG will be a sign I'll be using for withdrawing groups. So this is an electron withdrawing group, hence it takes away electron density from the chain, decreasing the electron density in the chain. Correct? And it is showing resonance just like this. Nobody will ask you to draw the resonating structures. Okay? Right now, you do not need to focus on how to make the resonating structures. You just need to know what increases the electron density, what groups show plus M effect, what groups show minus M effect. Okay? In this lecture, we're going to focus on just these things because we're going to focus on the acidity and the basicity order. When we are learning about the resonating structures, then we will come over here and again learn about how to make the resonating structures. But right now, that is not our motto. Everybody understood? Now, these are few of the groups which show electron withdrawing nature. Electron withdrawing groups, bacha, any group which either has a positive charge, right? Either has a positive charge or has a multiple bond in it. Multiple bonds in it. Right? Positive charge or multiple bonds will definitely show electron withdrawing nature. These are electron withdrawing groups and will show the minus M effect or the minus R effect. They are one and the same thing. Okay, so these are the groups. Can you see? In every group, there is a presence of a multiple bond, right? So multiple bonds, you just understand electron withdrawing nature. Very essential. Now, this is the order. Very, very important because trends will be asked कि nitro group is more electron withdrawing or your cyanide group or your aldehyde or your ketone group, right? So you need to know these orders. These orders are very, very important. Okay, for example, nitro will show the maximum minus M effect, then your CN group, then your aldehyde, then your ketone, then your ester, and then your amide. Very, very important order. Very, very important. Okay, now next. Yes, bacha, sulfonyl chloride has a S double bond O, right? So double bond, whenever multiple bonds come, right, there you have to show minus M. Any multiple, double bond, triple bond, any kind will show electron withdrawing without any exception. There is no exception in this case. Okay? Now next, we are back to some PYQs, right? As I told you, I've attached 15, more than 15, 16, 17, I don't know how many years of PYQs are here. So this is from your 2024 PYQ, the functional group that shows negative resonance effect. Negative means what? Minus R or minus M effect. Such basic question in your JEE 2024 attempt. Who can answer this question? The OH, the OR, the COOH or the NH2, which shows a negative minus M or a minus R effect. Who can answer this question? Who can answer this question? I'm looking at the chat box once again. I'll give you just 30 seconds to answer this. I am looking at the chat box. Please answer. Very, very basic. Plus M means what? Which increases the electron density. Minus M, which means what? Which decreases, which takes the electron density towards itself, right? C, aspirant has answered C. Rudra has answered C. Very, very good. The answer is COH, because this is the only group which contains a multiple bond. Extremely easy. This is the only group which has a multiple bond just like this. Hence, it is the electron withdrawing group. Hence, it will show the minus M effect or the minus R effect. Easy? Easy question? Correct. Let's move forward. Next is fourth factor. So, we discussed three factors up till now. Who can just recall it? Number first was charge. Okay, more the positive charge, more will be the acidity. Number second was electronegativity, right? So when we are moving along a period, as the electronegativity was increasing, the acidity was also increasing, correct? But as we were moving down the group, because the bond length increases, hence the acidity increases down the group. Correct? This is clear. The third was the resonance effect. The more the resonating structures, more stable the resonating structure, and more the resonating structures, more will be the acidity, right? Conjugate and the resonating structures of what? The conjugate base that we form. After removing the H plus, the minus anion that remained was called the conjugate base. So to know the acidity trend, we need to know the stability of that conjugate base form. So more the stability, more the resonating structure, more stable the resonating structure of that conjugate base, more will be the acidity, right? And we discuss what are the groups which show plus M effect, which show minus M effect, right? Now the fourth factor is the inductive effect. Very, very popular, very, very important, very, very crucial to know. Okay? Now, bacha, inductive effect means what? It means anything which can, there are two types of inductive effect. One is the plus I effect, the next is the minus I effect. Okay? So the plus I effect means what? So what we are forming after, see, I'll explain to you with one example. The one example is, for example, this is your COOH group. I need to know how acidic this is. So what is the thing that I need to know? That the conjugate base form, the H plus will be removed for the acidity. Acidity means what? How quickly, how easily can it give away the H plus ion. So the conjugate base formed over here, I'm writing CB for conjugate base, right? So we will look at the stability of the conjugate base. Can you see that the base will always and always have a negative charge on it, right? So we are looking at the stability of this anion. Every time, no matter what acid you're considering, you will look at the stability of some anion, some conjugate base, which will have a negative charge just like this. Okay? So we are looking at to stabilize the negative charge, that is anion, right? So there are two types of groups once again. The plus inductive effect, which means what? Which increases the electron density, which is called the electron releasing group. The next is the electron withdrawing group, right? So the plus I effect are shown by those molecules which increases the electron density, right? These are electron releasing group. Now to this base, if I attach a group, for example R, which increases the electron density, what it is doing? It is destabilizing this conjugate base, isn't it? Now this is already has a negative charge. I'm adding another molecule to it which is increasing negative charge on it, right? So it is destabilizing this, right? Because if I am negative, I want to become neutral, because negative, if either the species is negative or positive, it is not stable. Only neutral species are stable, right? So this negative charge will want to become neutral, will want to become stable. So if I'm increasing the electron density, hence this will not help in increasing the acidity. So if the electron releasing group are present, therefore they will decrease acidity. Remember this, correct? And similarly, when electron withdrawing groups, now to the COO minus, I am attaching, for example, a NO2 group. NO2 group is what? It is withdrawing electrons towards itself. It is an electron withdrawing group. Hence, it is decreasing the negative charge on it. Hence, it is stabilizing the conjugate base, right? So, electron withdrawing groups, if they are attached, they will increase the acidity. Everybody understood this? Everybody understood this point? Everybody understood this point? Beta, isomers we're going to cover in the next session. I have developed another session for just isomers. I know how much emphasis there has to be given on isomerism and also on this trend, right? So I have actually, because right now we have 1 month, we have proper 1 month before your JEE 2024 attempt to April attempt, where we're going to cover, you can just leave the chemistry part on me, at least specifically organic chemistry. For other chemistries also, I'm coming up with another series. They're going to be really short videos just for your help, topic wise, right? Because whenever you're looking, whenever you study topic wise, you will never forget how to answer the question. In exam, what happens, you know all the concept, but you do not know how to approach the question. That's why I've attached so many PYQs here. But before that, we need to know the theory, correct? So, but everybody understood this part? Everybody understood this part? Yes. Chalo. Now let us see with examples. What I explained to you, ki minus I effect will decrease the electron density and plus I effect increases the electron density, which means plus I effect are electron donating groups and this is the electron withdrawing groups. Okay? Next is, this is the plus I series. What is the plus I series? The trend in the plus I series is this, that your CH2 will give the electrons more easily than your NH minus, then your O minus, then your COO minus, then your tertiary alkyl. So can you see, as the negative charge is negative charge and your alkyl groups will actually increase the electron density in the ring. So this is the trend that is followed. Please look at this trend, very important. You'll get the notes in the Telegram channel. Now the minus I series is this. Minus I is electron withdrawing groups. So which are the stronger electron withdrawing groups? Which has a positive charge on it. NF3 plus, okay? NR3 plus, NH3 plus, then NO2, then CN, NO2, CN, then your aldehyde, then your carboxylic acid, okay? And then your fluorine, chlorine, bromine, iodine, then your alcohol, then your what is this? Ether group. Then your triple bond CH group, which is your acetylene group. Then your phenyl ring. Then your strained, and then this. Okay, so this is very crucial, important trend. You need to know what is the trend, which will decrease more, which will show more electron donating effect, which will show a lesser electron donating effect. Very important trend. Just look at this table once and you will understand. You don't have to even, ratify this table because this is so easy to understand. As the positive charge is increasing, it means what? That it will be more electron withdrawing group. Then will be your NO2, then CN, then aldehyde, then acid. Okay? Now next, we are looking, now these are some of the theoretical things that you should know about the inductive effect. For example, it is a permanent effect, first of all, because these theoretical things are also asked in your JEE Mains exam. Okay, we're not leaving even one thing behind. The next is that it is just a shifting of electron pair and not a complete transfer. What happens here? A complete transfer of electron doesn't happen. It's just a tug. This is the push and pull of electrons. The complete transfer doesn't happen. Correct? Okay? So therefore a bond polarization actually happens, correct? And why it happens? Because there is some electronegativity difference between the molecules. For example, CO bond will show the inductive effect. Why? Because your oxygen is delta negative, it is delta positive. Oxygen is more electronegative, hence it will pull the electrons towards itself. Therefore, it will get a negative charge, it will get a delta positive charge, correct? And hence, this polarization is also caused in the inductive effect. And the inductive effect actually, bacha, decreases with distance. Very important. Okay? It decreases from the distance. It means what? For example, this is the molecule CH3, CH2, CH2. Here it is again CH2, and here I have attached fluorine to here. Okay? Now what I've done, I've attached CH3, CH2, CH2 and F over here, and here is some other group. So as the distance is decreasing or the distance is increasing, then your inductive effect will have an effect. It decreases with distance. As the distance increases, it will decrease. Okay? Next. Now look at this trend. Now here the distance is mentioned. So can you see here a carboxylic group is present in every case. है ना? Acidic group is present in every case, correct? So what will happen? What will happen? After it gives away the acid, after it gives away the H plus, this gives away the H plus over here, this gives away the H plus over here, this gives away the H plus over here. What will happen? This will become a anion, right? And anion will be formed over here. Now we have to look which is more acidic between these three species. So wherever the stability of the anion is more, that will be more stable, correct? So can you see here the Br is attached right to that carbon, very near, right? Here the Br, the group remains same. Here also Br is attached, Br is attached, Br is attached. What is changing is their distance, because the bromine, which is what? Bromine is a electron withdrawing group, है ना? Look at this table, look at this table. Here bromine is a electron withdrawing group, minus I series, right? So because bromine is electron withdrawing group and it shows minus I effect, which decreases with distance, hence this will be more acidic, correct, than this, because the distance with bromine is increasing in each case. So as the distance increases, the minus I effect also decreases. It is an electron withdrawing group, which means what? It will take the electron towards itself, it will push the electron towards itself, it will pull the electron towards itself, right? And thus stabilizing this negative charge. Where the negative charge will be more stable? Where the minus I effect is the most. As the minus I effect decreases with distance, hence this, can you see? This is the most acidic. This is most acidic. Most acidic, hence the lowest pKa. Lowest pKa means most acidic compound. ठीक है? Yes, it is very distant dependent. Very distant dependent. Now, look at this JEE Mains 2023 question. Can everybody look at this question? Everybody look at this question. The descending order of acidity for the following carboxylic acid. Who can answer this? Who can answer this? See, A, B, C, D, E. You have to write the trend. Which will be the most acidic? Which one will be the least acidic? So tell me, A is more acidic, B, then C, then D, then E. Write down the trend. What do you think will be the trend? JEE Main 2023 question. Who can answer this? Yes, correct. Correct, aspirants. Less distance, more stable. Because at the least distance, minus I effect is most probable. Who can answer this? So what you have to do in each case? First of all, just lose the H plus in every case, right? Lose the H plus, lose the H plus, lose the H plus, lose the H plus. And what will be left behind? A negative charge will be left behind on each of these two. A conjugate base will be left on each of these two. Now, we have to look at the stability of these conjugate bases. Which conjugate base is the most stable? That will be the most acidic group, right? Very easy way. This is the only way to check the acidity. That you will never get it wrong. Never get it wrong. Always first take away the H plus ion, then form the anion, and then check the acidity order. So which is the most stable base? Okay, Rudra has written B, D, E, C, A and has told me that it is very easy peasy, ma'am. Minus I effect, yes, minus I effect will be shown. That is correct. That is correct. So which shows the maximum minus I effect? So here the CH3 group, can you see here the CH3 group is attached? The CH3 group actually shows a plus I effect. It is increasing electron density, right? The CH3 group is increasing the electron density. Hence, it will be the least acidic because we want to stabilize the negative charge. We need something that take away the negative charge from it. We need electron withdrawing groups. All the other groups here are electron withdrawing groups. That is, they show minus I effect. They are electron withdrawing groups. Now we have to know the order. Can you see in the B there are 3 fluorines attached, 3 electron withdrawing groups. Hence the most stable conjugate base. Therefore the most acidic is B. So B here becomes most acidic. Okay. Next is which one? Now in C, D and E. Now I know that only one halogen atom is attached, because I know fluorine has the highest minus I in the trend that we saw, right? It shows the most minus I effect, then it should be D, then it should be chlorine, which is C, then it should be E, and then it should be A, is the least acidic. Why? Because CH3 is an electron releasing group. So it is destabilizing the conjugate base. We need the conjugate base to be more stable, hence more the electron withdrawing group is attached to it, more stable it will be. If your answer was this, then you are correct. Okay? If your answer was this, then you are correct. Okay? Aspirant, what have you written? I can't understand. What is EPBT? What is EPBT? Okay? Okay, now let's move on to the next. Is the factor number 5. So we have discussed right now 4 factors. What were those factors? The number 1 factor, I'm again going to just repeat it the entire lecture so that it fits in your brain. Because all these factors you have to consider when you are looking at difficult question that we're going to look at in this lecture right now. Okay, this is the 5th factor. That before the 5th factor, the 4th factor was number 1, the charge. More the positive charge, more the positive charge on the H plus, right? On the hydrogen containing atoms, more will be the acidity. Number second was what? More the electronegativity along the period. Along the period as I'm going, if the electronegativity is increasing, the acidity increases. But down the group, what happens? The bond length increases, hence the acidity decreases. Number 3rd point was resonance. More the resonating structures, more stable the resonating structures of the conjugate base formed. How is the conjugate base formed? After removing the H plus, the anion that is formed is called the conjugate base. And more are the resonating structures of the anion, more stable are the resonating structures of that anion, more will be the acidity. The 4th was the inductive effect. Inductive effect means what? Ki there are 2 types of group, electron releasing and electron withdrawing groups. So more the electron releasing group are attached on the conjugate base form. It will decrease the acidity, right? And if the electron withdrawing groups are attached to the conjugate base, stabilizing the conjugate base, hence increase the acidity. Now the number 5th factor is the orbitals. Very crucial, important factors which nobody teaches you, and hence you always get it wrong in your exams when all these factors are mixed and a question is asked. So the factor is, bacha, that you should know the electronegativity order between the sp3 orbital, sp2 and the sp orbital. As we know that the sp orbital has the highest s character, right? It is 50% s character. Your sp2 has 33% s character, and your sp3 has just 25% s character. So as the s character is increasing this way, right, the electronegativity is also increasing, right? The electronegativity is also increasing this way. Sp is more electronegative, hence the acidity order. The acidity order is also like this, right? What does it mean? I will explain to you with a very, very important example. For example, look at this molecule, CH triple bond CH. I need to know the acidity of this molecule. Why am I saying that this acetylene is more acidic? Acidic means what? Which will give away the H plus easily. After it has given away the H plus, what is left? This kind of conjugate base is left. Everybody agrees? This conjugate base is left. Now we have to look at the stability of the conjugate base, right? More the stability of conjugate base, more acidic will be your compound. Now I told you that here, because triple bond is present, this carbon is sp hybridized, right? Both of these carbon are sp hybridized, which means it is a more electronegative carbon. Now understand this thing. More electronegative, what is the one thing that comes to your head? For example, more electronegative atom, ma'am, means oxygen or fluorine, right? Those are more electronegative atom. So in more electronegative atom, what kind of charge is more stable? Is positive charge more stable on them or a negative? For example, if I talk about oxygen, On oxygen, a negative charge is stable. Similarly, on fluorine again, a negative charge is a stable charge. This is a stable molecule. Why? Because they are already electronegative. Similarly, because I told you that here the carbon is sp hybridized, which means it is more electronegative carbon. So on more electronegative carbon, the negative charge is stable. Hence, I know that because the negative charge is stable on the sp hybridized carbon, so this acetylene is more acidic because the conjugate base formed is stable. As the negative charge is stable on more electronegative carbon, here sp3 carbon is not electronegative, least electronegative. Hence, this is least acidic. Okay, can you see? Therefore, acetylene is most acidic, then your sp2 hybridized, and then your sp hybridized carbon. Everybody understood? Everybody understood this point, which is a very crucial point. Okay? As the S character increases, the electronegativity increases and the acidity also increases. Okay? These are very, very crucial points. Next, now this is JEE Main 2024 question based on this important point that I just taught you, this important factor. Who can answer this? You just have to let me know the trend. The question is the ascending acidity order of the following H atoms. See, the H is circled, right? Which H is more acidic? You have to answer to me. JEE 2024 question means this January this question was asked. Who can answer me this question? 100% very clear, very, very good. Who can answer this question for me? Who can answer this question for me? The ascending acidity order. Yes, but just steric hindrance will also be there. We are going to discuss each and every factor one by one. Just wait with me. Wait with me. I will discuss every factor. Okay, Rudra has given me the answer A, B, D, C. Okay, let us see. So I know that here, let us look at the hybridization of each carbon. Okay, because everywhere the carbon is different. Here the carbon is sp hybridized. Okay, here the carbon is sp2 hybridized. Okay, here the carbon is sp3 hybridized, and here also the carbon is sp3 hybridized. Okay, so between A and B, I know ki because this is sp, which means more as character, more electronegative, more acidic. So A is the most acidic compound. Then will be your sp2 carbon, right? Because it is lesser electronegative. So then it will be B. Now I have to decide between C and D. Both are sp3 hybridized, ma'am. Now how will I check? Now, can you see here, 3 R groups are attached, 3 methyl groups. Methyl groups are plus I groups. Remember this, these are electron donating plus I groups. So, these are doing what? These are after this H is gone away, after this H is taken away, what will happen? This will get converted into a conjugate base. This will get converted into a conjugate base. Now we have to look at the stability of this base. Here 3 plus I groups are attached. Plus I groups. Here only 1 plus I group is attached. Can you see? Can you see here only, sorry, 1 second. What did I write away? What letter was that? Here only 1 plus I group was there. Correct? Everybody understood this point? Here there are 3 plus I groups attached to it. Hence, what will happen? What will happen? It will decrease the acidity. It is increasing the negative charge on it, but we want to decrease the negative charge to make it stable. Hence, this is the least stable, so then it will be D and then it will be C. A, B, D, C is the order. Correct, Rudra, correct. Rudra has been right. Everybody understood the point, right? So, if two are already negative, if I'm negative, if I have a very much negative charge on it and you are attaching groups to me which are increasing my electron density, how will I become stable? I'm already negative, you are giving me more negativity. How can I be stable, right? You need to take away the negativity from me, only then I'll be stable. So if you attach electron withdrawing groups on me, then I will become stable. Do not give me more electronegativity, है ना? ठीक है? चलो next. Next factor is hyperconjugation. Okay, this is again another kind of factor. Can you see here hyperconjugation what happens? So whenever, for example, to any sp2 hybridized carbon, for example, this is the carbon, This is the carbon. This carbon is sp2 hybridized. Everybody agrees to that, that this is a sp2 hybridized carbon, right? And to this carbon, if again another carbon is attached, and to this what is happening, the hydrogen atoms are attached over here. ठीक है? ठीक है? So now बच्चा any sp2 hybridized carbon, the carbon next to it, which is this carbon, understand, the carbon next to it, which is this carbon, should have too many hydrogen atoms. More the number of hydrogen atoms, this carbon is called the alpha carbon, because this is right next to the sp2 hybridized carbon. ठीक है? This is one sp2 hybridized. The next sp2 hybridized carbon bachcha can be, for example, in the presence of a benzene ring. This is a sp2 hybridized, and to this benzene ring I attach a CH3 molecule. Correct? So again, because this carbon again is sp2 hybridized, so this becomes the alpha carbon to it, and the hydrogens attached to it become the alpha hydrogen. So more the number of alpha hydrogens, these are alpha hydrogens. So more the number of alpha hydrogens, more will be the hyperconjugation. That is it. That is the only thing that you need to understand about hyperconjugation. What are its uses? What are its examples? We are going to study with examples, because with theory these effects are not that clear, but when you do the examples with me, everything will be crystal clear to you. Just remember the theoretical part about it. What does it mean? Hyperconjugation means, so whenever to a sp2 hybridized carbon, the next carbon attached to it, okay, the next carbon is called the alpha carbon. And if the more the number of hydrogens, attached to this alpha carbon, more will be the hyperconjugating structure and more will be the acidity. ठीक है? Look at this point. ठीक है? If this is this visible? Is this visible? This is not visible. It can be, I'm sorry, I forgot to make it in dark mode. I don't know how I missed it on. But the only thing that is written over here is, bacha, that, can you see this pen over here? Okay, this pen is also not visible. I'm going to write it here. The only thing is mentioned, more the number of alpha hydrogens, more will be the acidity. That is it. That is the only thing written over here. More the number of alpha hydrogen, more will be the acidity. Stability of carbocation is also mentioned, but we're going to study that separately so that we don't mix two things together. Right now, we're just studying about the acidity and the basicity order. ठीक है? Next is the aromaticity, the bigger bomb, aromatic compounds. Ma'am, what are aromatic compounds? Can you teach me more about that? So many questions that I just cannot do in exams. What is happening? I cannot solve the PYQs. Beta, I have arranged another session on just aromaticity. Right now, just understand basic few points about aromaticity, because sometimes aromaticity also helps in increasing the acidity. What are aromatic compounds? So what do I mean by that? For example, after losing the H plus, okay, whatever I'm saying, for example, you have a compound over here, RH. So after losing the H plus, it becomes R minus, right? After losing the H plus, it becomes R minus, just like this. And the negative ion that is forming, if for example, that negative, that anion that is formed is gaining aromaticity after releasing the H plus, then it will again be more acidic. Remember this point. So if after losing the H plus, the anion that is getting formed is aromatic in nature, then it will be extremely acidic, extremely acidic molecule. ठीक है? अब what are the conditions for aromaticity? You just need to look at those conditions for now. In detail, we are going to do another lecture. For now, you should know that any compound which is, first of all, should be a cyclic compound. Second of all, that it should have all sp2 hybridized atom. ठीक है? There should be no sp3. All atoms should be sp2 hybridized. Remember this. ठीक है? There it should be cyclic, and the all atoms that are in conjugation should be sp2 hybridized. ठीक है? Number second is, how many electrons should it have? It should have a total of 4n plus 2 pi electrons. Remember this. What does it mean? Let us look at these compounds. Can you see this compound over here? How many electrons it has? I can see that, ma'am, here it has just 1 pi bond, and we know that 1 pi bond has 2 electrons in it. Hence 1 pi bond, it means 2 electrons. If I put it in this manner, if I put 4 and 0, if I put the n key value as 0, I will get 2 pi electrons. Hence this follows the Huckel rule, which is the 4n plus 2 pi electron rule, right? If I put n is equals to 0, what answer I will get? I will get 2 pi electrons. This has 2 pi electrons, hence this is aromatic. Now here, look at this molecule. How many electrons does it have? It has 2 pi bonds. Hence it has 4 electrons. Can in any way 4 electrons be the answer according to this formula? If I put 4n, n key value is equals to 0 is equals to, which means 2 electrons. If I put n key value 1, then the answer will be 6 electrons. But here there are 4 electrons. So 4 electrons do not follow this Huckel rule. Hence this is not aromatic compound. Now look at this compound. It has 6 electrons in it. Therefore it follows the Huckel rule. So you do not have to put n is equals to 1, 2, 3, n is equals to 0, 1, 2, 3. Every time when you're looking at the aromaticity of the compound, you just have to know what? That the aromaticity starts with 2 electrons, and after that just keep on adding plus 4. For example, 2 plus 4 is 6. Okay? So the next aromatic compound will be a 6 electron compound. Okay? Now 6 plus 4 is 10. So the next aromatic compound will be a 10 electron compound. If I add 10 plus 4, then it is 14. Then the next aromatic compound will be a 14 electron compound. Okay? So you just have to know that I start with 2 electron, and after that keep on adding 4, 4, 4. And if these electrons match with the electrons in your molecule, then that molecule will be a aromatic molecule. Okay? Everybody understood this? Everybody understood this? Shall I move forward about the aromaticity? Aromaticity. Okay? Now comparison of all the effects that we are doing. So we need to compare all the effects over here. So I taught you that you can decide on the basis of so many effects. Hai na? So many effects were what? First of all, inductive effect, resonance effect, hyperconjugation effect, and aromaticity effect, right? So all these effects were applying to your molecule. Now, if you have any molecule where you have to decide that which factor will weigh in more, which factor will weigh in less, should weigh in less, then what should be the trend for? What do I mean by that? You will only understand after we do the examples. Right now, just remember that this trend is followed. The trend is that resonance, the structures which show resonating effects will be more acidic. Then will be the hyperconjugation will be given more emphasis. Then it will be given the inductive effect. So the inductive effect is given at the last. Okay? Inductive effect is treated like the last. And even before the resonance, the one factor that is given more priority is the aromaticity. Right? If any molecule is getting aromatic after losing the H plus, it is becoming aromatic, it will definitely be most acidic. Then if any molecule is gaining resonating structures, it will be more acidic. If any molecule is having hyperconjugating structure, it will be more acidic. Then it will be the inductive structure. Please remember this trend. So aromaticity, then your resonance, then your hyperconjugation, and then your inductive effect. This is the last priority order that you have to follow. What do I mean by this, ma'am? I do not understand what you're saying. You will understand once we do the examples. Okay? So just stay with me. We are going to do everything with examples. Correct? Correct? Let's move forward. So now the examples have begun. I've told you all the theory. All the theory is complete. Now we're just going to look at the examples. Before that, let us revise once again. Everybody is on, what do you say? Is with me with all the factors that we saw for the acidity basicity order, right? Number 1 factor was charge. Number 2 factor was the electronegativity along the period down the group. Number 3rd factor was resonance. Number 4th factor was was inductive effect. Then number 4th factor was hyperconjugation. Number 5th factor, aromaticity, right? And then we compared which will be given more priority. right? Now let us do all the questions based on all these things. I've covered everything and all the questions are here in front of you. You are going to solve these questions. I'm not going to do anything. I know. Which of the following is strongest Bronsted base? Which is the strongest Bronsted base? Who can tell me? Bronsted base, we're going to tell. We have to tell. What is a base? I'm again telling you, a base is anything which can donate its electron. A base is anything which has the capacity to donate the electrons. So which will be the stronger base which can donate maximum number of electrons, right? Stronger base, bacha, will be what? Stronger base. Stronger base will be anything which donates maximum electrons, right? Donate maximum electrons, right? So which among these has the most electron donating nature? Now, ठीक है? D. Rudra has told me the answer is D. Correct, Rudra, correct, Rudra. But I'm going to explain to you once again. Electron donating means what? See, here the NH group has what? Lone pair of electrons. So everywhere, ma'am, there is a NH2 group. There is here also a NH group. Here also a NH group. So what does nitrogen have? Electron pair. Lone pair of electrons it has. So it can donate its lone pair of electrons. But the donating capacity is actually reduced. How? Can you see in this case what is happening? The electrons can take part in resonance over here and here. So here the lone pair of electrons on the nitrogen can take part in resonance on both these rings. Hence, the availability of electrons to donate has become less, right? Because it is taking part in resonance. Therefore, the electrons available to donate for the basicity becomes less. Hence, this is least basic. Then come over here. Come over here. Now, can you see here the electron pairs are present over here, right? And 2 pi bonds are here. Now what happens in this case? Now can this molecule donate its lone pair of electron? This cannot donate its lone pair of electron. Why? Because this lone pair participate in aromaticity. Remember this thing. This lone pair participate in aromaticity. Why does this lone pair? Because can you see here 1, 2, 3. If I add these electrons, these pi bonds contains 2 electrons. There are 2 pi bonds, hence 4 electrons are already present in this molecule. But if this lone pair also contribute to the aromaticity nature, then it will become plus 2 electrons. Then hence it will become a 6 electron molecule. Therefore, these electrons actually participate in aromaticity. Hence, they are not available to donate. And hence, this will be the least basic. This looks to me as the least basic because the lone pairs are not even available to donate. Now, look at this compound. Again, here the lone pairs are available to donate, but they will again participate in resonance with the benzene ring, right? Benzene ring resonance, it will participate. What will happen? The benzene ring has a structure like this. This will move over here and it will form too many resonating structures. Because this is participating in resonance, the availability becomes less. But in this structure, what is happening? There is no aromaticity, there is no participation in resonance, hence this lone pair of electrons is free available, is free, right? So hence this is the most basic compound. So I'm going to name this as A, this is B, this is C and this is D. Hence I'm going to write the basicity order over here. Over here I'm going to write the basicity order, basicity. Correct? So which is the most basic? Most basic is D. After that, the most basic is C. After that, most basic is A. And the least basic is actually your B compound, because B, all the electrons are participating in resonance, hence it will not donate. So the basicity order is this. Basicity depends upon the capacity to donate electrons, right? The availability of electrons should be maximum for it to act as a base. Is this point clear to everybody? Is this point easy peasy pizza tasty bol rahe hain Rudra? ठीक है, चलो next question. JEE Mains 2024 question once again on your screen. Which of the following has highly acidic hydrogen. So I'm going to mark the hydrogen. This hydrogen they're talking about here, and this hydrogen they're talking about here. Probably here they're talking about any hydrogen you can take. You can take this hydrogen, you can take here this hydrogen. Okay? Now tell me which hydrogen is the most acidic hydrogen. Again, how will you look at this thing? After losing the H plus, whenever you are asked this question, which is most acidic, which is you have to do what for the most acidity? Just lose the hydrogen and form the conjugate base. So wherever the conjugate base is most stable, it will be most acidic hydrogen. Hi, Mr. Sathya Creation. Hello. So which is the answer to this question? Where do you think the conjugate base formed after losing the hydrogen will be more stable? I have got, Rudra has answered 1. Rudra has answered 1. Okay. I'm going to look at your answer. Number first, again, what I'm doing, I'm just making a conjugate base. I'm losing one hydrogen. Okay, losing one hydrogen and making a conjugate base. Similarly, I'm making a conjugate base here. I'm making a conjugate base here, and I'm making a conjugate base here. Okay, I've made all the conjugate bases, which is after losing the H plus, a negative ion is formed. Okay, just remember this thing. Now, where the negative ion is more stable? I think in the fourth option, can you see the negative ion here? It can donate. What is happening? It can get 2 resonating structures out of here. This can donate its electron even to this and even to this molecule. Why? Because it is connected to 2 kinds of electron withdrawing group, right? These are electron withdrawing groups. Any multiple bond that you see will be an electron withdrawing in nature. This is a very good electron withdrawing group. Hence, this will withdraw the negative charge on it. So, this negative charge is more stable on the fourth option. Everybody understood this? So, I just have to look at the stability of the conjugate base formed after the H plus is gone. So, wherever the conjugate base is most stable, that will be the most acidic hydrogen. Here, after losing the hydrogen, this negative charge can resonate between these 2 electron withdrawing natures. Hence, this is the most acidic hydrogen. The option number 4 is true. Okay? Rudra, aspirant, Abhinav, everybody has answered the wrong thing. Wrong thing. No, bacha, no. No. Here you have, I told you, whenever we are talking about acidity, basicity, you have to consider all the trends in place, right? All the trends, all the hydrogens over here are sp3 hybridized only, bacha. All the carbons are sp3 hybridized. I'm not seeing any double bond anywhere. The only difference is in the placement of the electron withdrawing groups, right? Now, because here the negative charge can get displaced to 2 sides, which means that it is getting more kind of resonating structures. More the resonating structures, more stable will be the anion and more will be the acidity. That's what I told you. That's what we discussed about. Henceforth is the answer. If you have any confusion in this answer, please let me know. Otherwise, we'll move forward. Henna? Everybody understood this, or shall I move forward? I'm going to select my yellow pen once again. I don't like the blue. Okay? You understood this, right? Yes or no? If you have any silly-pilly doubt, now, please ask me. That's the main reason for live classes. Otherwise, I would have recorded the session and just put it, right? Here, you can ask me any silly-pilly question. I can answer, like, I'm here to answer your questions, right? If you're here to study, I'm here to answer your questions. I'm here to answer. I'm seeing 0 questions right now. Did you understand or not? Did you understood this concept or not? Please let me know. Rudra, Abhinav, aspirant, please answer to me. Chalo, I'm moving forward then. Yes, Sreshta Salai Singh, yes. Now next is the correct order in aqueous medium of basic strength in case of methyl substituted amines. So, bacha, amines. In amines, again, very clear. Okay. In amines, they have asked you the basicity order in the aqueous medium in case of amines, and many options are given to you. So bacha, in amines there is a different kind of trend is followed. What trend is followed we're going to learn again in this session. So can you see, this is amine. What is amine? Where there is a NH2 group and a R group is present over here, right? This is a amine group. Everybody understand this, hai na? So here what is happening? What is happening? We have to look at the basicity order, right? So this alkyl group, as I told you, is a electron donating group. Hence it is increasing the electron density on the ring. Hence this alkyl amine is actually more basic in nature, right? It is increasing the electron density. Hence it is increasing the electrons on the NH2 group. Hence this is more basic in nature than your ammonia, right? So this is your ammonia molecule. How do you prepare amines? You prepare amines by replacing one of the hydrogens with NH2 and R group. Then you can replace another hydrogen with another R group, right? So what you're doing, you're replacing the hydrogens with R group and forming amines. And we know that R group is actually an electron releasing group. Hence it is increasing the electron density on your nitrogen. Hence it is increasing the basicity. This thing is clear to everybody? Okay? Similarly, in case of aniline, aniline is what? When it is attached to a benzene ring. And we know in aniline what can happen? This electron pair on ammonia can actually take part in resonance. Hence, the basicity of aniline actually decreases. Hai na? So, aniline basicity decreases, but alkyl amines basicity increases due to the introduction of these kind of alkyl groups. For example, if I form R3N group. So R3N group is more basic than R2N group, right? Is more basic than RNH2 group, right? Is more basic than your ammonia group. Is this thing clear to you guys? Hai na? So this is the order followed in gaseous state. Gaseous state. This is not the original order. You will think ki ma'am, because as the alkyl groups are increasing, the plus I effect is increasing. I'm increasing the electron density on nitrogen. Hence, the basicity order should be this. But it is not the order when in aqueous solution. What happens in aqueous solution? I will let you know. In aqueous solution, bacha, this is the trend followed. What is the trend? Can you see that here? Secondary amine. Okay, we're going to look at this thing once again. So, this is a tertiary amine, right? This is a secondary amine. This is a primary amine. Does anyone have any doubt in it? Because 3 alkyl groups are attached to the nitrogen. This is a tertiary amine. 2 alkyl groups are attached to nitrogen, secondary amine. 1 alkyl group is attached, primary amine. Correct? Everybody understood this? Now let us look at, what is this, ma'am? This is nothing. I've just shown you how this aniline actually decreases in basicity because the electrons are now not available to donate. They are now resonating inside the ring. They are forming so many resonating structures. Hence the basicity decreases, right? Basicity is decreasing. Basicity decreases. Okay? Now the next is here the actual order of basicity in your solution state is what? Secondary amine when your ethyl group is attached. What group is attached? Ethyl group. So secondary ethyl amine is more basic than your tertiary ethyl, then your primary ethyl, and then your ammonia. Similarly, when methyl groups are attached, which is a smaller group. So here again secondary amine is more basic than your primary amine, then your tertiary amine, and then your ammonia, and here again, then your ammonia. Why is that the case? See, again, when you're dissolving something in solution, what is happening? Let me draw the structure of tertiary amine. If I draw the structure of tertiary amine, the structure will look somewhat like this. Here it is N, here it is CH3, here it is CH3, here it is again CH3. So can you see that there are too many CH3 groups attached to a tertiary amine, which is causing what? Which is causing steric hindrance. Steric hindrance. So due to the presence of steric hindrance, the availability of the lone pair of the nitrogen becomes less. Can you see in solution state we're taking care of all these things? What all other things that we're taking care of? Number first is your plus I effect. Okay? What all factors are coming into play? Plus I effect, I know. Hana, plus I effect will be there. Number second factor is your steric hindrance. Steric hindrance, right? So as the steric hindrance increases, the basicity will decrease because the availability of lone pair will not be. It cannot attack as good as it could attack in the secondary amine case. Okay? And the third factor is because we are putting it in water. So the energy that is released is called the solvation energy. Okay? Again, this solvation energy is again very, very important. So these three factors we consider when we talk about basicity of amines. Remember, only and only amines I'm talking about here. So whenever you're talking about amines, this will be the order. If to the nitrogen ethyl groups are attached, secondary amines will be more basic than your tertiary amines, then your primary, and then your simple ammonia. But if primary amines are in position, then primary, can you see? Secondary amine, then your primary amine, then your tertiary, and then your ammonia. Okay? I am changing these groups over here. Here's the ethyl group, here it is a methyl group. Everybody understood this point? Yes. Now look at this example. Now again, I am taking you back to the JEE Mains 2023 question. Who can answer this? The correct order of aqueous medium of basic strength of methyl substituted amines is what? What was the order? Secondary was more basic than primary, then tertiary. Remember? Remember, so the correct answer here seems to be C, isn't it? C seems to be the correct answer. C seems to be the correct answer. So C will be the right option. Okay? I'm again taking you back to the next question as in JEE Mains 2019. See, these kind of questions are repeated. Hence, all of these trends are very, very important. Look at this question. In the following compounds, decreasing order of basic strength will be again. See, in 2023, methyl group was asked. Here, the ethyl group is asked. So, we've discussed all the two groups. Now, what will be the trend of the basicity? Which is more basic and which is least basic? Which is most basic and which is least basic? C, Rudra has replied. Beta, to this question, please reply to this question. Here, which will be the most basic? Here, the most basic here seems to be 4. This is a very easy question, right? This is like the 4th seems to be the answer. Hello? See, here this seems to be the answer. Secondary, then primary, and then ammonia. Correct. So here D seems to be the answer. JEE Mains 2019. Easy question. Hello, you're understanding these questions. Now we are back to JEE Mains 2023 questions. So we've discussed all the exceptions that can be there. Now you have to just apply everything that I've taught you as of now. Now look at this thing. Which will undergo deprotonation most readily in basic medium? Again, do not be very much overwhelmed by the question. This question is very easy. Deprotonation means what? Deproton is a H plus ion. D means you have to remove H plus. So again, in the other way, when we are removing H plus, when we do that, when we look at the acidity order. So IB, this is the same question as the acidity order. Okay? So the question, they've just, like look at the language of the question. They will just try to intimidate you with the language of the question. It is which will undergo deprotonation most readily. Okay? So where the H plus ion will be released easily. That is the question. So where will it be released easily? Where the conjugate base formed will be more stable, right? After releasing the H plus, wherever the base form will be more stable, that will be the easily the deprotonation will happen. So wherever the conjugate base form is more stable, that will be your answer. Correct? That will be your answer, isn't it? Isn't it? OME is electron donating group. Yes. So I'm going to explain to you. So once again. For example, if I take out hydrogen from here, in this first compound, if I take out hydrogen from here, so this will become a conjugate base like this. Here again it will become a conjugate base like this, and here again it will become a conjugate base like this. So I'm removing hydrogens from here, here, here. ठीक है? ठीक है? Now next is among these three, where is it more, the conjugate base is more stable, है ना? So now look at these options. Now first of all, look at the C option. What is happening in C? Here can you see that there is an oxygen present over here? Oxygen can undergo another thing. Oxygen can give its electron pairs to here and undergo resonance with this structure, right? So here oxygen is getting a resonance under this structure, right? And here this negative charge. How will this negative charge be stable? When it undergoes resonance. More the resonating structures, more will be the stability of this negative charge, which we call conjugate base. So what is happening in this case? This can undergo resonance over here, and this can undergo resonance over here as well. Correct? Here this will again take up into resonance, this will again take up into resonance, right? So there in the C part, this negative charge is getting into two resonating structures. I can see that, but can you see that to the second double bond O, to this second double bond O, this OMe is also utilizing it for resonance. Hence, here the resonating capacity of this negative charge actually decreases, correct? Because here this oxygen is also using up the next C double bond O for resonance. Here, hence this negative charge will get less chance to form resonating structures. Similarly, in this case again what is happening? There are two MEO groups here. These will again utilize these carboxylic atoms for resonating structures. Hence, this negative charge will get lesser chance to participate in resonance. But here what is happening in option number A? Both of these are electron withdrawing groups. Hence, this negative charge can take part in to form resonating structures like this, right? And there is no other group attached to it which is hindering the resonance, which is doing what? Which is utilizing up the resonating structures, correct? Correct. So here the only correct option seems to be A, because all the rest of the species that are given are utilizing up the carboxylate, the carbonyl ion to resonate with itself. Hence, the negative charge that is formed will get lesser chance to form resonating structures. Hence, the stability decreases. The highest stable here seems to be the A option. Again, everybody understood this? ठीक है? हाँ जी. OMe is an electron donating. Yes, you can look at it in this way also, that OMe here, the OMe that is attached, right? The OMe, because it is donating the electrons, it is increasing the electron density, right? It is already a negative charge here. The OMe is increasing the electron density in the ring. Hence, it will be the least acidic, right? It will, the negative charge will not be stable on it, right? So the answer will be A, correct? You can look at it in this format also. Everybody understood this? This is also the correct format to look at. Correct, Rudra, you are right about it. You are right about it. ठीक है? Now next, move on to the next thing, bacha. Among the following, marked proton of which compound shows lowest pKa value? Which shows the lowest pKa value? Who can answer this? Who can answer this? Again, what do you mean by lowest pKa? Please concentrate on these terms. Lowest pKa means highest acidity, right? Highest acidic. Correct. Lowest pKa means highest acidity. These are inversely proportional terms. ठीक है? The hydrogen is marked for you. The hydrogen over here is here. This one is here. It is this, and this here. This is. ठीक है? So among these marked proton, which shows the lowest pKa, which means which is the highest acidic hydrogen? Who can answer this question? Again, the best way to look at is just remove the hydrogen and form the conjugate base. Wherever the conjugate base formed is more stable will be the most acidic hydrogen. Isn't it? Isn't it? Hanji, I'm looking at the chat box. I'm not telling you the answer till somebody tells me the answer. Till somebody tells me the answer. Now let us start removing the H plus one by one. Ma'am, is phenyl carbanion stable? No, bacha. No. No, no, no. and here the phenyl is not formed. This is called the benzyl. Understand the difference between the two. If I form something like this, this is a phenyl carbanion. This is a phenyl carbanion, right? But if I form something like this, here it is a CH2 minus. This is called the benzyl carbanion, right? And phenyl is least stable. It is not never ever stable. Nothing is stable in phenyl. Benzyl, very, very stable. Extremely stable. Anion, cation, whatever. इसमें भी phenyl carbanion, phenyl carbocation, all are very unstable species. Benzyl carbocation, carbanion, very extremely stable species. ठीक है? Understood this thing? La, 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 la. I think students are not serious about studying right now. Hanji, I am getting answers. Sujan has told fourth is the answer, and so has Rudra. Rudra and Sujan has said that fourth is the correct answer. Let us look at the answers. So the correct way to look at it, after I lose this proton, a negative charge will come here. After I lose this proton, a negative charge will come here. After I lose this a negative charge, and here again a negative charge will be here. Everybody understood this? Now, where is the negative charge most stable? Where is the negative charge? Here a C double bond OH group is attached. C double bond OH, here C double bond O CH3 group is attached. ठीक है? Here C double bond O CH3 group is attached. Here C double bond O OH. So here बच्चा what is happening? है ना? I can cancel out these two options A and B. Why? Because here electron withdrawing benzene ring is attached. Always remember that benzene ring is a electron withdrawing group. Okay? So whenever a benzene ring is present over here, it is an electron withdrawing group. So it is electron withdrawing over in this case. It is also causing an electron withdrawing nature. So when I compare the alkyl species with the aryl species already has the electron withdrawing group. Hence, I have to compare between these two right now. है ना? Because this has already become lesser stable because there is only one C double bond O group here, which is the electron withdrawing group. Here also only one C double bond O group is here, which is electron withdrawing. है ना? But in this case, what is happening? In this case, now here CH3 is a plus I group. Can everybody remember this? CH3 is a plus I group, and here the OH is present. OH is also what? Electron donating group. है ना? So between these two, how will you decide which is more acidic? Which is more acidic? Now the answer that I got is the answer D. Answer D, that, okay, I've got three answers. Sujan, Rudra and Aspirant have all given the answer as D, which seems to be the correct answer. Now, ma'am, how did you decide that? How did you decide that? So, this is causing a plus I effect, already increasing the electron density in the ring. है ना? But here, oxygen, even though it shows what? It is showing this kind of resonance, right? It can show this resonance, which is called the plus M resonance, because it is increasing the electron density towards the chain. है ना? I just taught you plus M effect. But this oxygen is also electronegative in nature. Remember this thing. So, because oxygen is already electronegative, so it will withdraw electrons also. So, it also shows another effect, which is the electron withdrawing effect, which is a minus I effect, because there is oxygen, which is a electronegative atom. Hence, D seems to be the correct answer when you have to compare between these two options, right? When you have to compare between these two options, then D seems to be the correct answer. ठीक है? Next. Next, JEE Mains 2022 question. Arrange the following in decreasing acidic strength. Decreasing acidic strength. Who can answer this question? Very easy question. Again, acidic strength is asked means what? Just remove the H plus and look at the stability of the conjugate base forming. In that way, your answer will never be wrong. Who can answer this question for me? Who can answer the question for me? Also, please like the sessions, everybody, whoever is watching. If you haven't liked the session, please like the session. Hannah, if you like the session, right, and whatever feedback you have, please write in the comments section below, not in the chat box. Later on, after the video is over. Okay, Rudra has given me the answer, A, B, C, D. A, B, C, D. Okay, Rudra, I got your answer. Now, decreasing strength. Now again, what will I do? I will take away the H plus in all the cases. I'm taking away the H plus in all the cases and I'm making a phenoxide ion just like this. Now I have to look at the stability of this anion formed, right? Here nitro is an electron withdrawing group. Here nitro is an electron withdrawing group. Here OCH3, two kinds of OCH3 is present. Right, OCH3, what kind of, so I'm going to teach you another very specific thing which you should know and you will only understand when you do these examples. So can you see here nitro, what effect does NO2 group show? So NO2 group shows, first of all, minus I effect. It is an electron withdrawing group, right? The second effect is it also shows the resonating effect, right? It also shows the minus R resonance. Through resonance, it takes away the electron. So minus R effect is only and only shown at the para position. Remember this thing. Similarly, here, so I've talked about this thing. Now I will talk about this. The B part. The B part, what all effect will be show? The nitro group at the meta position. Can everybody see? The nitro group at the meta position only shows the minus I effect. Remember this thing. Similarly, the OCH3 group over here. The OCH3 group at the meta position only and only show the minus I effect. है ना? OCH3 group here can also act as a donating group also. It shows a minus I effect here, and here it can also show at the deep, actually it shows the minus I as well as the plus R nature. Correct? So this is the, at the para position only the resonating effect will be shown. Whenever you're comparing, these kind of things, always remember that the resonating effect will only be shown at the para position, whether it is plus resonance or the minus resonance, which means whether it is increasing the electron density or decreasing the electron density through resonance, it will only be shown at the para position. At the meta position, only and only the inductive effect will be shown. Okay? Here oxygen, because it is electronegative in nature, it can show the minus I effect, right? Can show the minus I effect. But between the nitro and the OCH3, between nitro and the OCH3, which will show more minus I effect, I already told you, we have to look at the trend. NO2 is more minus I, is given more priority for the minus I effect. Hence, the electron withdrawing groups here are these, all the three shows the minus I effect, but here it also shows the minus R effect. Hence A will be the most acidic group. Okay? Because here the negative charge is stabilized by minus I and the minus R effect. Here what is happening? Again, then B will be the answer. Then it will be your C, and then it will be your D. So Rudra, you were absolutely extremely right. This is the answer. Okay? Hi Siddharth, thank you. Everybody understood this? So first of all, just write which group will show what effect. So both of these groups, whether NO2 or OCH3, will show the minus I effect, because OCH3 oxygen is an electronegative group, so it will show the minus I, electron withdrawing nature. But the resonating effect is only shown at the para position, right? So for the nitro at the para position, it will show the minus resonating effect, but the OCH3 at the para position will show the plus resonating. What it is doing? It has lone pair of electrons and it is donating the electron back to the ring. But nitro is taking away the electrons from the ring. Correct? So this is the final order, and when we have to compare between B and C, we know that the electron withdrawing nature of NO2 is much more than your OCH3 group. Hence, this is the final answer. Everybody understood? Everybody, hi Sheikh. Hi Sheikh. 75% in physics. Wow. How was your physics exam? Who are here from the 12th class and you're still studying chemistry? I'm very proud of you. Very proud of you. Okay, how was your physics exam? Please let me know. 75% is actually great. I hated physics in 12th. I literally hated it. I wish I had sir like Shreyas sir, right? At that point of time. Now the next 2021 question. The correct order of acid character of the following compounds. Again, we have to look at the acidity. What you have to do, just remove the H plus, right? And whatever conjugate bases form, whichever conjugate base is more stable will be more acidic. Correct. Which is more acidic? Again, you're from 12th. Oh, Rudra, how's your physics exam? Rudra is like a very, very old student, I can say. Right? We have been interacting since I don't know when. On so many channels, right, Rudra? Rudra is a very loyal student. Average, same. My physics exam was so bad in 12th. I do not even want to talk about it. It was the worst day of my life, probably. Average. Ma'am, what is a group R on the para rather than a meta? What do you mean? I don't understand you, Himanshu. Last question. Here, the NO2 group is there and OCH3 group is there. What was your question, Himanshu? I don't understand. I didn't understand your question. Please reframe it so that I can understand. If you're comfortable in Hindi, then you can write in Hindi also. I know Hindi. Okay. Chalo, ye wale ka, who can answer? Who can answer this question? Acidic character. So here again, lose the H plus, it will form a phenoxide ion. Lose the H plus, it will form a carboxylate ion. Lose the H plus, carboxylate ion. Lose the H plus, carboxylate ion. Everybody understood this? Everybody, yes, you are a JEE aspirant, as you should be, okay, if you are here on this channel. Okay, and we will do the JEE Bacha this year. Okay, this April attempt, especially for organic chemistry, you can depend on me. I have curated an entire syllabus. We will finish within this month. Everything, each and every question will be covered. We'll go slowly, right? We'll also go fast later on, but right now we're going slowly so that you understand each and everything. BCDA Rudra has said. Okay, so now look at the stability of these conjugate bases. NO2 is a electron withdrawing group. What all effect it shows? It shows minus I effect as well as minus R effect. Correct. Similarly, here there is no group, but here there is a CH3 which shows plus I nature. That is it. Right. Now to look at the stability of the anion. How can I make it stable? When I'm putting electron withdrawing groups on it. Electron withdrawing groups will make this stable. This benzene ring is again a electron withdrawing group. So here NO2, this ring is the most acidic. So second bacha is the most acidic. Now between this will be the most, and then between phenoxide, carboxylate, and this, which will be the answer? The next one will be your third number here, right? Because this is a plus I effect here showing, then it will be fourth number, and then it will be first number. This is the correct answer. BCAD. Okay? Beta, don't be scared, especially for chemistry. We are going to cover everything. Okay? I've also created another very short video series for you guys where every topic we're going to cover in like 15 to, because I am teaching now, so I cannot promise you 15 minutes because I don't want to leave even one thing, right? If you leave one thing, then so many questions will be hampered due to that. When I'm teaching, I don't leave even one thing for you to learn, because that's the way I learn and that's how I want my students to learn, to just give time, because now we have time. 1 month is enough for chemistry. Okay? And if you attend my 2-hour lectures each day we're going to do 2-hour lectures. Everything we'll complete within this month. So just give 2 hours to organic chemistry and just revise it within 30 minutes the same day. Okay? With same day, and then again 30 minutes the next day. Just try to accumulate it. Your organic will be stronger than rest of India. I can guarantee that if you're following me. Okay? This is the order that is followed. Now, can you see that phenol is less acidic even due to this plus I group? Because carboxylate anion, this COOH group is always more acidic than the phenol group. Hence, this will be the trend followed. Second, third, fourth, and first. Everybody understood this? Everybody understood this? Shall I move forward? Yes, I'll take the responsibility, Siddharth. I will take the responsibility. And I'm here to take the responsibility as a whole organization that we stand for, है ना? Because you have given so many positive results, you can depend on every teacher on this channel, and on organic especially organic right now I'm saying, because I've curated the entire syllabus for that. So organic, just do not go to anything, just look at these videos, because I've only made your end, your end of the part very easy for you. Okay, everybody understood this? This is the order followed. If you have any doubt in this order, please ask me. Carboxylic acid in any way will be more acidic than phenol, even if a plus I group is attached to it. Okay? Even if the plus I group is attached, even then it will be more acidic than the phenol group. Move forward. Okay. Now, which of the following compounds possesses the most acidic hydrogen? JEE Mains 2020 question. Which of them possesses the most acidic hydrogen? Again, which will be the most acidic hydrogen, that after I take away the H plus, the conjugate base form should be more stable. So if I take away H plus from here, this will become a conjugate base. If I take up H plus from here, this will become a conjugate base. If I take up H plus from here, this will become a conjugate base. If I take H from here, this here will become a conjugate base. This wala atom. Let me write it clearly. Let me write it clearly. Yes, here. Negative. Okay. Now answer this question. Fourth, Himanshu Yadav has said fourth. Rudra has said A. Okay. So the correct answer is actually fourth. Himanshu is right. Rudra, you are not right now. Now look at the electron withdrawing. I know on what basis Rudra has said the answer, but I want to emphasize again on one more thing. Here there are only 2 electron withdrawing groups. Can you see? C triple bond and only 2 electron withdrawing groups. Any group which has a multiple bond in it is an electron withdrawing group, right? So we need to stabilize the negative charge. The negative charge will be stabilized by the electron withdrawing groups. So here only 2 electron withdrawing groups are here, right? And in the fourth option, inhi dono mein you should have confusion. In the fourth option, there is actually 1 electron withdrawing group, 2 electron withdrawing group and 3 electron withdrawing groups. Can everybody see? We have 3 electron withdrawing groups in the third option. Hence, this hydrogen will be more acidic than your first. Okay? So that's why this is the answer. Here only 1 electron withdrawing group is there. Here also only 1 electron withdrawing group, which is your sp, hybridized carbon. So this is actually, sorry. So this is actually the most acidic hydrogen. I've made a clearer diagram for you to understand. A clearer diagram. Here there are too many electron withdrawing groups. 3 electron withdrawing groups are attached. Hence this is the most acidic hydrogen. Okay? Here it is the most acidic hydrogen. Okay? Next question. The increasing order of basicity for the following intermediates from weak to strong. Increasing order of basicity. Who can answer this question? Let me look how many questions are remaining. Okay, right now there are too many questions remaining. We will not be able to complete. Okay? So this is, I'm giving you a homework question. We are going to begin again from this question for the next session. Okay? We are going to make a part 1, part 2 of this. This is going to be the part 1. Okay? This is a homework question. Let me know in the comment section below. And I'm going to discuss the answer in the next session. It is already going to be 6. So I'm going to meet you again tomorrow. We're going to continue the acidity, basicity, because I am going to do each and every PYQ here on the session. We're not going to leave even one PYQ, which is very crucial. Number 2, we're going to discover the stability of species, which I have not done yet. So we're going to complete this in part 2 tomorrow. Thank you for attending the class. If you have any doubts, any question on any of the questions that we have done, or any problem in any of the theory that we discussed, okay, we can, ma'am, can't we complete now? Bacha, because right now again there's going to be Namrata ma'am's session, because maths exam is going to take place. So she is going to take class at 6 p.m. I cannot take her session, but we're going to complete it tomorrow. I am here on this channel for from 4 to 6. We're going to study from 4 to 6 p.m. So whatever doubts you have, no matter in what, especially in organic chemistry, whatever we're studying, please meet me 4 to 6 every day. We're going to cover everything topic wise and cover each and every PYQ. Each and every, not even one is going to miss. And ask me questions, ma'am. Why did that happen and why did that not happen? So that you open your mind and are able to solve more questions more effectively. Thank you for attending this session. Thank you, thank you, thank you. Bye bye, everybody. Bye bye. Please let me know the answer in the chat box below.